This is the AB Calculus prep session we had last Saturday, November 21st, 2015. And my section of the course had to do with PVA. And PVA is short for position, velocity, and acceleration. And so we're asked to see where we are and evaluate from a certain level, and then maybe go to acceleration. And acceleration, which is a of t, is equal to the first derivative of velocity. And v we'll just call v of t. So we're looking for this kind of relationship and so forth. So let's look at the problem at hand, which is the fourth problem. An object moves along the x-axis with initial position x of 0 equal to the velocity of the object at time t is greater than or equal to 0 is given by v of t equals the sine of pi over 3 times t. And so we're looking at what is the acceleration of the object at time t equals 4. So what we'll need to do for that is I'm going to put a up here. And acceleration, a of t, is equal to v prime of t. So we take the first derivative of velocity, and let's go about that. We have sine of pi over 3 times t. So let's go ahead and take the first derivative, which is going to be cosine. The derivative of sine is cosine. And so we're going to have pi over 3 times t and times the derivative of the inside of the argument. And the inside, pi over 3 times t, is going to be pi over 3. So we're going to now put in 2 for that. I mean, not 2, 4. Where is that? At t equals 4. So we'll say a prime of 4, a of 4 is equal to v prime of 4, which equals cosine of, now t is 4, so we're going to have cosine of 4 pi over 3 times pi over 3. And the cosine of 4 pi over 3, it's, if we look at a unit circle like this, at pi, we have pi over 3 here, we have 2 pi over 3 here, and down here in the third quadrant we have 4 pi over 3. And for that, our cosine is going to be negative 1/2. And so going back, we take a of 4 equals v prime of 4 equals negative 1/2 times pi over 3, which equals negative pi over 6. And we look for our units here, and I don't see any units or in meters or anything, so this is going to be our answer to part A. Now let's look at part B. Consider the following two statements. Statement 1, for between t between 3 and 4.5, the velocity of the object is decreasing. Well, if acceleration is negative, that means that the velocity of the object is decreasing. So for part B, we say statement 1, we say, instead of the following two statements, we will say correct. Why? Because A of t, which equals v prime of t, is less than 0. Therefore, let's see, velocity is decreasing. Now, next we get down to statement 2. And for that, we need to examine the velocity. So let's do that. We have the equation v of t equals sine of pi over 3 times t. Well, let's go ahead and we're going to plug in. We'll find v of 4. We already have a of 4, right? Or v prime of 4. So we're going to say is equal to sine. And we have 4 pi over 3. And going back to our unit circle, okay, just drawing that unit circle again, we had down here in quadrant 3, 4 pi over 3. And for this, the sine is going to be equal to negative square root of 3 over 2. So we say v of 4 is equal to negative square root of 3 over 2. And then now we're going to go and be able to complete our statement 2. We say since we'll say since a of t, which equals v prime of t, is less than 0, and v of t, or v of 4, is less than 0. By the way, we should just I should put 4 up here for that, shouldn't I? Since v of 4 equals v prime of 4 is less than 0. Equals v prime of 4 is less than 0. And v of 4 is less than 0, right? Because we had negative square root of 3 over 2. The speed of the particle is decreasing and why? Since a of 4 and v of 4 have the same sign. The statement is correct. Now, I think this was a calculator problem. We could have graphed and saw between 3 and 4.5, but we were fortunate to have already worked out the acceleration at t equals 4 and find that negative, and we went and found the velocity quite easily at t equals 4. So for this question to make part B to make any sense, we would have to be able to examine probably any value within that interval of 3 to 4.5, and which we did at 4, so this should be correct, is correct. Good luck, and thanks for viewing.